Let's look at some examples of how interp and type check should work with let type and type case. In the case of interp with let type, um, then the result of this interp is going to be the result of the body. If we have a 1 in the body, then we just return 1. So that wasn't so interesting. Let's write an example that does involve apple or banana. Let's suppose that the body here is apple 1. So that is, we've introduced the variant apple here of the fruit type, and now we're instantiating that variant by supplying the field value 1. So what should we get out? Should we get an apple v out? Apple v is the sort of thing that would happen at the plate level, right? You would get a new kind of value specified by the variant here, but that would be at the plate level. And we can't, every time we add a new let type in our curly program, go change the plate interpreter to add a new apple v, banana v, and so on. So this isn't going to work out. What we need to do is have a generic variant v type at the plate level. That variant v represents a record of some variant tag and then some field value. And that's why it's convenient that all of our variants have only one field at the curly level. We can represent that using a variant v having a type tag and one field value at the plate level. So again, if we did apple 1 inside this let type, we should get a variant v with the tag apple and the field value num v1. If we instantiate banana instead, banana has type num arrow num for its closure, so we could put this function here as the argument to banana. Then we get a variant v with banana instead of apple and the closure value inside of it. What if we return just apple by itself? In Plait, you can use a variant name just as a function, and you could pass that function around if you want to. You can use it as a value. So we should do the same thing in typed curly, and this is going to be a function apple, but it's a function that takes an argument and creates a variant v. So to implement this primitive kind of constructor, we need a new kind of function. We're going to have a constructor v function. So constructor v is similar to a close v in that it's something that can be applied, but unlike close v, its implementation is more primitive. And the information we need to know about its implementation is, what is the tag to apply to a variant. If we return banana, then we would get constructor v banana instead. Let's look at type case now. So here we've got let type and type case. This apple 3 does create a fruit, so it's consistent with this type case. And of course we should dispatch to this first clause of the type case, bind a to the field value 3 here, and we're returning a, so that's why we expect to get a 3 out. If we had created a banana instead, banana with this function inside, then b stands for that function, and here we're applying that function to 7, so 7 goes in for x, we add it to 3, and that's why we expect a 10 out in this case. So there's nothing new about how type case works here. You're familiar with that from Plait. It's just a matter of getting used to the syntax with let type instead of define type.